Finite Math, Chapter 5, Section 4, Annuities, Present Value, and Amortization. The present value of an annuity. In Section 3, we examined annuities that accumulate funds. Now we're going to look at payout annuities, like receiving payments from a retirement account or a winning lottery ticket. The present value of an annuity is the amount that you must deposit today to provide all of the payments for the term of the annuity. And here's our formula. The formula is that the present value equals R, which stands for payments, 1 minus the quantity 1 plus I, and again that's annual interest divided by number of compounding periods per year, to the negative n, number of compounding periods over the term, divided by I. Shorthand notation for this is P equals R times A and angle I. The present value deposit for accumulating funds is the one deposit that you make today to produce the future value of the annuity at the same interest rate and for the same time period. For example, how much do I need to put into a savings account today in order to accumulate $500,000 in 25 years at 3% interest compounded monthly? All right, let's try an example of this. Jim Riles was in an auto accident, and he sued the person at fault and was awarded a structured settlement in which an insurance company will pay him $600 at the end of each month for the next 7 years. How much money should the insurance company invest now at 4.7% compounded monthly to guarantee that all the payments can be made? All right, we're going to use our formula. Pause the recording, give it a try, and resume the recording to check your answer. Okay, this is an ordinary annuity. Our payment is $600 a month, that's R, and is 7 times 12, which is 84 payments over the course of the annuity here. I is 0.047 divided by 12. Putting all those numbers in, we see that they need to invest $42,877.44 now to have enough in the account to pay off all of the payments. This one's a little different. We have Surinder Sina and Maria Gonzalez. They're graduate students and they want to contribute to an endowment fund at the college. And Sina says he will give $500 at the end of each year for 9 years. Gonzalez prefers to give a single donation today. What should she give to equal the value of Sina's gift, assuming the endowment fund earns 7.5% interest compounded annually? Pause the recording, think about it, see if you can do the problem, and then resume the recording to check your answer. All right, we're going to look at what Sina's gift will have grown to by the end of 9 years. So we're going to put the information we have there into the future value formula. And we're going to find out that his $500 payments over 9 years will grow to $6,114.92. Now we're going to keep that, kind of lay that aside. That we'll use that to double check the rest of our work. So for Gonzalez, we need to figure out what the present value would be. What could she contribute today to get that? So what we're going to do is take the same information but put it in the present value formula. So we put in the $500 payments, the interest, and we discover that the present value of Sina's gift is $3,189.44. Now, if you want to double check that and make sure that that's indeed going to grow to the same amount as the first gift by the end of the term, what you can do is put that into the compound interest formula, which you see there, and we find that when we use the compound interest formula for $3,189.44 at 7.5% interest for 9 years, it does indeed grow to the same amount. All right, a coupon rate is the interest paid by a bond, and it's not always the same. In fact, it's often different from the interest rate at the time of the bond's purchase. And remember that bonds do pay simple interest every 6 months except for zero coupon bonds. So when a bond is sold before maturity, which does happen frequently, the price of the bond is not going to be its face value. Instead, it's going to be based on the current interest rates and not on the interest rate of the bond itself. So we're going to look and see how that works. Okay, we've got a 15-year $10,000 bond with a 5% coupon rate that was issued 5 years ago, is now being sold. The current interest rate is 7%. What should a purchaser be willing to pay for this bond? Okay, let's talk through this. First of all, according to the simple interest formula, the interest paid by the bond every 6 months is $250. So we're going to think of this in two parts. First, if you're planning on purchasing this bond, you're going to have $250 every 6 months for the next 10 years. The second thing we have to consider is that at the end of that time, the face value of the bond, the $10,000 face value, will be returned to you. So the purchaser should be willing to pay the present value of each part of that investment, assuming 7% interest compounded semi-annually. Remember, 7% is the new interest rate. The interest rate per period will be 0.07 over 2, and the number of 6-month periods in 10 years is 20. So first of all, we're going to do the present value for the $250 every 6 months for the next 10 years. We'll put that into the formula, and we find that the present value of that $250 is $3,553.10. Then we're going to do the same thing with the $10,000, and this is a lump sum, so we're going to go back to our formulas we had in previous sections. So we have 10,000 times 1 plus 0.07 over 2 to the negative 20, and we get $5,025.66. So the purchaser should be willing to pay those two sums put together, $8,578.76. Now, a loan, from a bank's point of view, is an annuity, and it's paying a fixed amount each month, and they are the ones getting the payout. And the present value is the amount borrowed. So let's do a loan problem. Chase Bank in April of 2013 advertised a new car auto loan rate of 2.23% for a 48-month loan. Shelley Fasulco will buy a new car for $25,000 with a down payment of $4,500. We're going to find the amount of each payment. Okay, see if you can do this. Pause the recording, give it a try, resume the recording to check your answer. Okay, she pays $4,500 down, so what's left is $20,500. We're going to use the present value formula for the annuity with P equal to $20,500. N is 48-month loan, and I is 0.0223 divided by 12. And then we're going to solve for R because we're looking for the payment. And here's the math. Putting all the numbers in, we find that she will have to pay $446.81. A little bit about amortization. A loan is amortized if both the principal and interest are paid by a sequence of equal periodic payments. Here's our formula. The payment equals the principal times I times the interest. And again, remember that's interest over the number of compounding times over 1 minus the quantity 1 plus I to the negative n power. Note that while your payments are equal, the amount that goes toward principal and the amount that goes toward interest is not equal, nor is it always the same. What you find with a loan, with the amortization, is that your payments on interest, the amount of your payment that goes toward interest is high at first and it gradually lowers, while the amount that's going toward principal starts low and increases with time. As the loan is paid off, the amount of payment going toward interest lowers, while the amount pays down, the principal goes up. Little technology tip, remember that TVM solver we talked about? Well, you can use that to help you here too. Fill in the known information, put the cursor next to the unknown item, and then you solve. The remaining balance is the amount that's due on a loan after a given number of payments have been made. So if you wanted to pay the loan off after a certain number of payments, that's your remaining balance. Here's the formula. You can figure it out. In the formula before we move on to the amortization schedule. B stands for balance, R stands for your payment, X stands for the number of payments that have already been made. The amortization schedule is a document that outlines how loan payments are split between interest and principal over the term of the loan. And we also have a formula here that will come to the present value for annuities due. We did future value in the previous section. This is going to be the present value formula. And again, notice it's slightly different from the present value for an ordinary annuity. All right, let's try a problem or two. Beth Hill borrows $1,000 for 1 year at 12% interest, compounded monthly. We're going to find her monthly payments. And then we're going to, part B, after making 5 payments, she decides to pay off the remaining balance. About how much should she pay? Pause the recording, try your formulas out, and then resume the recording to check your answer. Here's the first part, putting our information into the formula. We find, into the payment formula, we find that she will have to pay $88.85 per month. And then for part B, using our remaining balance formula, she has $597.80 remaining. There is a part C to this, and that is to construct an amortization schedule. And I went ahead and put it up here because we haven't really talked about that. Here's what the schedule looks like. Payment number 0 has nothing but principal. And then we put in the payments. That goes in column 1 after the payment number. Interest. How do we figure out that she has to pay $10 interest? Well, what you do is you take the principal at the end of the period, so the $1,000, you multiply it by the interest divided by the compounding period. So 1,000 times, I think it was 0.12, it's 12%, so 0.12 over 12. That gives you the $10. You subtract that from the $88.85, and that tells you the rest is going to go to principal. And then you subtract the payment from, or you subtract that from the $1,000, and that gives you the principal that's left, which is $921.15. Then you do it all over again. $88.85 is her payment. 921.15 times I gives you $9.21. Notice it's gone down. Subtract that from the $88.85. The portion that goes to principal is $79.64. Subtract that from $921.15, and you have the remaining principal. And you continue this until you end up with 0. Notice at the very end, $88.85 would actually be going over the amount that's left. So sometimes your last payment will be slightly different. Okay, here's another problem. Read over this. You've got 2 options. You won $12 million. You can take it in payments over 26 years. The other option is to get a lump sum, and the commission can earn 4.88% annual interest. What is that cash value? Now, before you do the problem, this is going to be an annuity due. You get the payments at the beginning, so you need to use the annuity due formula. Pause the recording and give it a try. Okay, once you know it's an annuity due, you know what formula to use. It's pretty easy. Instead of $12 million, if you take a lump sum, you get a little over $7 million. Here's a summary of our formulas. And here are a few problems to try. As you go through these, pause the recording, give them a try, resume the recording to check your answer.